Hello ladies and gentlemen, and welcome to the screencast for finding the limits of a graph, find the limits of a function graphically as x approaches infinity or negative infinity. But we're going to mix in some other problems like we've been doing, finding the limit as you approach from the left and the right. So let's take a look at this. First we want to find the limit of f of x as x approaches 1. So if we move along the graph here, you notice 1 is down here towards the bottom. So as we approach 1 from the left, the limit is 4. Negative 4. No, it's 4. Sorry. As we approach from the right, the limit is 3. Because they don't match, we say the limit as x approaches 1 does not exist. So now let's take a look at the limit of f of x as x approaches 5. Well, if we approach 5 from the left, x is 5, we find y is 5. When we approach from the right, we find that the limit there is still 5. So if you can find that same value from the left and the right, then we say the limit of f of x as x approaches 5 for this function, the limit is 5. So now let's take a look at what happens when x approaches infinity. Well, if you look at this, this looks like an asymptotic curve. So it's an asymptote. And here's a line of y equals 6. Well, that graph is going to continue to the right and in an upward direction, but because of the way it appears on the graph, it's trying to get to a value of 6. So we would say that the limit of f of x as x approaches infinity, the limit would be 6. It may never get to 6. It looks like it's an asymptotic curve. So it'll never touch that line of y equals 6, but that's where it's heading. It wants to attain that value of 6. That's why we can say that the limit as you approach infinity would be 6. Now let's take a look at this one. What is the limit of f of x as x approaches negative infinity? Well, negative infinity we're going to find this way on the left side. So x will continue to move left and y will continue to move up, both unbounded. There's nothing to stop them. So there's no line drawn that would lead us to believe that this curve heading left and up would be asymptotic. So at that point there is no bound on that. It will continue forever up and left. So the limit does not exist there because we can't put a number on it. Infinity is a concept, not a number, and if you recall, the definition of a limit is the numerical value of what the function is trying to attain. Alright, so let's take a look at the next one. Different kind of a graph. So if we take a look at this, and let's look at the first one, the limit of f of x as x approaches negative 3. So I'm going to approach negative 3 from the left, and the limit would be 3. When I approach x as negative 3 from the right, I get the same value. So since I have the same limit from the left and the right, the limit of f of x as x approaches negative 3 would be 3. Now let's see what happens when we look at the limit as x approaches negative 1. So we're going to approach negative 1 from the left, and we trace along here, and the limit from the left is 1. Now we're going to find, as we trace along from the right side, the limit there is 2. Since they don't match, we say the limit does not exist at negative 1. Now let's take a look at the limit of f of x as x approaches infinity. Well, this curve, as we move towards positive infinity, will continue up and to the right, apparently unbounded. There's no line that leads us to believe that there's an asymptote here. So we would say the limit does not exist. And if you look at as x approaches negative infinity down on the left, that limit does not exist either. On the next page are 2 practice questions. So if you need to replay the video, go ahead and replay it. But what I'd like you to do is try 1 and 2 on your own and I'll be looking to see that you've made an attempt at that in class. So this is the screencast for limits from the graph as x approaches infinity.